Cisco is a series sponsor of our ebooks on Docker and the container ecosystem. Learn more about Cisco's perspectives on these timely and important topics in our latest ebook on automation and orchestration. The ebook is available for download at thenewstack.io. Hey, it's Alex Williams of the New Stack here today with my friends from Cisco who've been working on some interesting projects there. Guys, great to have you here. We have Ken Owens of Cisco and Ben Schumacher, also of Cisco. Great to have you guys.
Yeah, thanks, Alex, for having us. And as you mentioned, I'm with Cisco, and I'm the CTO for Cloud Engineering and Strategy.
Yeah, thank you for having us, Alex. This is Ben Schumacher, and I work for Ken. I help. I'm an innovation architect, and I help sort of direct our container and microservice strategy for Cisco.
Excellent. So tell us a little bit about Cisco's perspective right now on the ecosystem, and what are some of the trends that you're starting to see right now? And I'm curious in particular, there does seem to be more emphasis on automating these stacks, so to speak, especially as we see the different demands and different types of workloads that come with the scale out of container environments.
Yeah, definitely. There's as you kind of look at where we've come from sort of infrastructure and cloud orchestration and automation, which used to really just mean kind of orchestrating the compute and the virtualization and the storage aspects with sort of user management and user provisioning into that system, right? As you kind of move from that to this new container ecosystem, you're kind of seeing all of that underlying infrastructure sort of becoming sort of infrastructure as code, and the ecosystem around containers and Mesos and Kubernetes around orchestration and scheduling with Marathon as well, kind of bring in a whole new interesting layer. And from Cisco's standpoint, we're very interested in not just what's happening in that layer from a kind of a cloud native development standpoint, but we're also interested in what are sort of the enterprise like feature sets around quality and around workload and cluster management to granularity that our customers require. And how do we enhance that with better networking capability, better service discovery and service management capability, and better security capability?
So can you explain what Mesos and Marathon are for people who may not be familiar?
I can do that pretty quickly, I think. Mesos was inspired, well, actually it was an independent project that ended up providing capabilities pretty similar to what Google used to call their org scheduler, I believe, unless it was Omega. I forget the names, but in the idea with Mesos originally, was it Omega? Yeah. The idea with Mesos originally was that it was started by a grad student. Was how can we make all of my compute and across these this variety of machines more accessible. And so he wrote what is effectively a kernel abstraction across multiple pieces of hardware, and it gives you the ability to easily schedule workloads that can really maximize your resource utilization across all those boxes. And then Marathon is the more, I would say, accessible version of how you work with that scheduler, and it works around containers, right? And it can schedule Docker containers, and it works very much like it provides a very fine-grained access to those resources. So you can very, very clearly say, I need 2 CPUs and 2 gigs of memory. And between Marathon and Mesos, it goes out and finds those resources across your boxes and runs your container there. And
so then what's the role of Mantle for people who are out there who are trying to grasp these concepts and terms?
Mantle is Cisco's curated take on how to sort of run a container stack, and it's we like to say it's a batteries included but optional way to get very quickly from having a whole bunch of boxes to being able to actually start putting containerized workloads on there. And we use a lot of open source and technologies from various partners. Obviously, MOSA is a big part of that, Marathon. And then we've used a lot of things from HashiCorp to enhance our sort of service discovery story. We've done some things with the Elk stack. It's all kind of familiar names, but it's one of those areas where, teams have spent a lot of time trying to understand how to make all of these things work together well. And we try to give you a really solid, out of the box starting point.
I think just if I can add to that, I kind of look at, the Mesos component as more of your scheduling and kind of managing some of the aspects of workload scheduling and placement. And Kubernetes is sort of the orchestration, and then Marathon sort of the orchestration pieces there. If you kind of think about like a layered diagram of sort of this, of what happens in sort of your data center, you have your physical hardware, you have, could just be using like any sort of operating system, and virtualization could not be, and it doesn't have to be in there. And then above that, you kind of have your container engines that, in the case of Mantle, we support Docker today. From a scheduling standpoint, as far as the next layer up is where we kind of have Mesos running. The orchestration layer today is kind of the next layer above that, and that's where we would have like Marathon, and we're supporting Kubernetes in the future release on Mantle. And then sort of you have your workflow management on top of that, and that's where a lot of the HashiCorp tools come into play in terms of how we manage those workloads and schedule those the policies and the aspects related to sort of workflow and cluster management.
Okay, so let's look at that. There's a holistic way to look at this as kind of like these larger perspectives on orchestration platforms. Perhaps what might be helpful for people here is to discuss these orchestration platforms right now and how they're maturing. We increasingly hear people talk about pipelines, for example, and the needs to automate these pipelines so these new kinds of infrastructures can live up to their promise. And a lot of that comes down to kind of issues around trust and such. So I'm curious what you guys are thinking about orchestration platforms right now. Perhaps we can dive into it from there.
Yes, I can kind of give like a high level overview, and then Ben can add to it if you like. So I think in general you're absolutely right. There's a couple of aspects to this pipeline capability that's important. One of them is definitely security and trust. And so how do you sort of know that these services are enabling the right workflows that have been allowed by this user to kick off in this cluster, right? And so there's definitely a lot of work still being done in the space, and that's where we've been in Cisco. We've been focusing a lot of our time on sort of the trust aspect, the service discovery piece of this, creating a user namespace and making it so that we have a little bit more of a true identity that's logging into a system, true set of services that are being spun up that we can call it by name, and we can actually validate, and part of our testing of these services to spin up, we can know that they are trusted and can be spun up. The other aspect that's interesting here is around the granularity for the cluster management, right? So as you think about spinning up services, the first question that might come to mind is how do you ensure that you don't have any kind of collisions in the different namespaces that you're deploying into, or that you have priority for some workloads over others. And so as you think about some of the enhancements that probably need to happen in the space, we've been spending a lot of time lately on kind of looking at how do we ensure kind of the priority of a specific container over other containers if necessary.
Yeah, how do you do that? What are some of the thinking behind that?
The main thinking that we have behind that is sort of around the concept of service affinity and kind of service priority. And so as you think about something like I call it application intent, but as you kind of think about from a business objective, what's the kind of intent of this application, and what are the components that make up that intent? And really it comes down, in a large way, it comes down to kind of how you architect your application, which I think is probably a bigger discussion that we should probably get into a little bit later. But as you kind of think about, how do you compose your application architecture into these composable services? The next logical question then is, once you have these logical services and you feel like there's the right degree of granularity, but not too much, then the next question becomes, well, how do I kind of, deploy these services in a way that if I have a failure in one specific host, I don't take down my entire application because I put all my, my orchestration, all my management, all my control plane in the same host as my user plane stuff, and everything just went down on that host. And so there's a lot of different factors, as you'd imagine, the fact that they kind of go into looking at sort of the prioritization of containers and workflows and workloads on those inside the clusters, and spinning clusters up and migrating clusters. All of these certain configuration parameters have to come into play. But I think the main way that we've been thinking about it is making sure that there's a user space that you can actually define these primitives. If we don't have sort of declarative primitives around defining this, it makes it a lot harder in the industry to actually ensure that you can do these priorities.
So that user space, tell us more about that.
So the user space is very similar to what you would have in kind of a traditional enterprise environment today, where you have different domains, and those domains have different subdomains, and you create your application. You would have certain, your application name would follow a corporate standard that would have something about the application name in it, so you know which, kind of where this server or this container fits within the overall architecture of the application you're deploying. And so it's sort of creating, IP addresses and domain names on a per instance or a group. You can even group. The nice thing that we're thinking about here, you can actually group a set of services together inside a single, network domain, and call all of this, your back-end web service, right? And you might have 100 containers or 1,000 containers making up that service, but there's one IP address to reach all of them. And if any one of them fell or have an issue, we just spin up another one, right? You don't have to worry about, maintaining the state of every single container. You just want to maintain the state of the overall group of services.
Well, what do you guys like to call that? Do you guys like to call that semantic infrastructure, an immutable infrastructure?
Yeah, probably immutable infrastructure is how I look at it. I don't know, Ben, you want to add anything? I know I've been talking for a while.
No, I don't think I have much to add. I do think the immutable infrastructure fits here, and really I think the really important part that we try to stress when we think about this is, making it really clear from the end user's perspective, and also the your developer as well as your ops people or CIO, the people who manage the budget, like what the guarantees you've built into the system are based off these groupings, and sort of what the cost of that is.
The groupings and the cost. And so what are some of the methodologies we're seeing for developing these groupings?
The first grouping you'll see will be kind of a natural extension of what a lot of enterprises define today in terms of SLAs, mm-hmm. or what they sort of expect from the infrastructure today. And so things like CPU and memory and I/O. If you kind of look at there's some examples on and we kind of look at a tool that the Cisco's been developing called Shipped. We have a deployment, created a deployment environment piece. We sort of separated the build from the deploy. And then that deploy piece, we have a few examples of some simple, sort of primitives. Like, one of them is, solid, requiring like, a solid state drive, right? So having, consistent storage performance. But there are lots of areas that kind of thinking around where we're at today that you can see easily kind of moving into this model. Some of the new things I think containers, or at least microservices in general, sort of can buy us in the future is looking at events like a security breach or a security issue. If we have as we detect these security events, right? Things like 0-day in the way we're looking at microservices in the future, 0 days don't become as much of an issue because we can detect these anomalies very quickly. And as soon as we detect an anomaly, we can then sort of have a policy that says quarantine this cluster of servers that's showing this anomaly, and then let's spin up these exact services in a different cluster, so the application doesn't have any downtime. And if the same anomaly occurs again, then we know there's an issue inside the application, right, that we need to fix. But I think you could see some natural extensions of where having a microservices approach and kind of that service design methodology approach can really help you sort of identify not only where there's a problem, but if you need to address that problem, you can address it much quicker and much more in sort of a automated fashion.
So when you talk about the ability to notice it quicker, what is it about this new architecture that allows you to detect it quicker? There just seems to be such a deep complexity that comes with these distributed environments. That just makes the need for more and better tools to manage these issues. But what is it that you're saying in particular that it is easier to detect these issues? How come?
The simplest explanation I have is if you think about a large system that's a complex multi layers within the system, trying to isolate the problem to a single layer is not easy to do, right? And so if you break those complex layers into smaller composable systems that are sort of independent and loosely coupled with the other services that they require, you can pretty much at some point get down to isolating where that issue is much quicker. Now, this is, what I'm saying is more kind of where I see us going in the industry as quick as we can get there, right? What is very true today, and Ben can spend lots of time on this if you want, is today once you send off a request to one of the scheduling tools, any scheduling tool out there does this, you don't know what happens, right? You send it off and maybe it's successful and you get a success. Sometimes you get a success and it wasn't successful. Sometimes you send it off and you wait 5-10 minutes and you get a failure back, or you get nothing back. It just keeps spinning, and you have to go log into different consoles as you kind of step down through the chain of what gets kicked off by what tool, and then you figure out, oh, this is where the problem was, right? And so definitely today the orchestration and the scheduling has a lot of, I think you called it new tooling or new visibility that's needed, and we definitely see that as well, and that's something that Cisco is working on to sort of not in a heavy needing agents type of way, but just in a very logical, very progressive way. How do we contribute to the upstream community in these different open source projects to provide the right level of visibility for what's happening inside those processes that get kicked off, so we can do a better job of sort of identifying where the orchestration is failing and what part of that orchestration is failing. And so there's two pieces of this, I guess I would say. One is the application architecture being in a more microservices architecture with services being different containers can really help you isolate and fix issues in the application layer much faster. But the orchestration or the control piece of this still has a lot of tooling that's needed and a lot of enhancements that's needed to get the understanding of if something in the underlying provisioning or orchestration or workflow placement layer fails. There's a little bit more work that's needed in the community there, and that's something Cisco is contributing very heavily to right now.
Yeah, and I would double down on that. The tooling needs to be better. I do think, and we're making progress, and I think there's a lot of advancements going. I mean, obviously the folks at Docker are moving very quickly, and there's interesting things coming out of a lot of these other, companies that are working in the ecosystem. But I think the the tooling is advancing. Having more visibility is important, and I think one of the areas that Ken sort of mentioned earlier that I think helps with the addressing these security issues quicker too is when we get into policies for how the microservices tend to work together, and I think this is one of the areas that I really see us at Cisco investing more time into is applications have a profile. I would say, like, they have a behavior that's typical, that's common, and can be modeled. And to sort of identify these potential issues, you can actually, once you figure out what the profile is of your application, A calls to B regularly, and B calls C, D, and E, and so on and so forth. You can actually very easily identify when something's kind of out of the ordinary. Wait a second, why is container E all of a sudden trying to go back and talk to A, right? And so first of all, I think it's, from a security perspective, you can help isolate those things by being very aware of sort of your, call flow of your application, and establishing policies that prevent that crosstalk, so to speak, that indicates that there's perhaps something, or that would indicate that there's potential security incident. But also, look at tools that can help you identify those and highlight those based off this application profile.
So the tooling is advancing. How is it advancing?
So I think there's a lot of different advances, and it's almost too big of a topic to get into. I don't mean too big of a topic to get into, too big of a topic to like fully cover in detail. I mean, yeah. So I think like going back to like the CI/CD, the sort of pipeline idea, right? Like I think that's what you mentioned that earlier. I think these next generation, cloud native architectures, the continuous delivery is a huge part of it, and there's so much sort of work that needs to go into, or there's so much value in having sort of an automated pipeline that can help you orchestrate the various microservices and push out the new containers as your engineers are adding new code to the repositories, fixing issues. And again, when you get back into microservices, one of the key benefits of the architecture is this decoupling, right? And so, if your software delivery pipeline, your SDLC, it really is focused on continuous integration, continuous automation, but specifically like being able to test each of these services in isolation, have some sort of gate perhaps in place. I mean, like teams have different sort of levels that they want to have gates. There's still a lot of teams that want to have, a manual review process. There's teams that have gone sort of entirely automated with their deliveries. And have it so that sort of every step of the way, like as a component is built, it can be validated against the versions that are running in production through some sort of automated testing process. And assuming it passes all that, you can automatically push those updates on either on a schedule or do some sort of rolling upgrade A/B testing. That's where I see the value of the CI/CD pipeline, is getting new code into production quickly and very quickly providing feedback to your engineering and development teams.
I think just to add to that, Alex, from a kind of more general standpoint, I think what I see in this ecosystem is Ben mentioned Docker with the recent release, and there's always going to be, I think, releases in this area to help improve some of the tooling from like Mesosphere and Docker and CoreOS and others. And I guess my only concern has been these are sort of like vertically integrated packages, right? You have to sort of buy A, B, C, and D to get the full support that you need, right? And I think the the true value of what we're trying to do in this new microservices architecture is make things more, I guess plug and play is the wrong word, but more of a integration and orchestration play than a true, you have to buy into this entire stack.
Okay.
I think if you think back to some of the PaaS solutions out there, I think that's where PaaS sort of had its biggest issues, that you had to sort of buy into their way of doing things. And if it didn't fit their way, you were sort of stuck, right?
That brings up a lot of debates about, opinionated systems and such.
And I think opinionated systems are okay to have, like to some extent, like some of the things that Cisco is doing will have opinions, but if it's an opinion that cannot be, is not flexible enough to change and adapt to new capabilities, then you're kind of stuck with the legacy system, right? And so I think that's where you have to be kind of careful with how much do you opinionate versus how much do you opinionate with the ability to adjust to current and future changes.
So how do you guys think you need to make things more of an, integration? What's your guys' thoughts on making things more of an integrated play, right? And less about a single kind of stack environment? Because we are starting to see that tendency. So what's your guys' thoughts?
So one of the big things we're doing is we've joined one of the founding members of the CNCF, which is the Cloud Native Computing Foundation, and the OCI for Open Containers Initiative, right? And so we're trying our best to kind of help bring the community together and make sure that we enable not just another, large tent sort of foundation, but actually a foundation that helps the end user community and helps keep things on the track that we're talking about here. That's one big thing that we're doing that's very, very active right now and early days, but I think you'll see the outcome of the CNCF and the OCI much different than a lot of the other foundations in the past, just because of the way that all the groups coming together and the end users that we're bringing into it from the beginning have a completely different view of what we want as an outcome than what you typically would have in this space. The other thing I think is that we talk as much as we can about extensibility and frameworks and being able to take advantage of new technologies, new capabilities, because that's frankly what has been the history of our field, right? The ability to move from one technology to the next gen technology seems to be like a constant battle in enterprises since the beginning of IT, right? And so I think if we can say we're going to try to address that problem as an industry, I think that puts a lot of weight behind keeping things from being too single vendor oriented or focused.
So thinking about, the CNCF, right, in the role that it plays, one of the things I'm curious about is, for example, is if, let's say we get into issues like cluster management, right? And you start thinking through, how you have these fine-grained controls. What are those fine-grained controls over the cluster? So you, for instance, can prioritize the workload, right? So you can start thinking differently about even the schedulers and how they're prioritizing and how you're allocating the different resources according to that prioritization. How are those issues going to be addressed by a body like the CNCF? I mean, I talk with IBM and they talk about a universal set of APIs, for example. Is that the path that you guys see, or what, or is there something different, or what's your view?
Yeah, I would say, I'm a member of the CNCF, so I kind of have a little bit of the insider knowledge, right, of what we're trying to do. Right. So it might not be quite a fair question for me, but the objective is very much to help drive the adoption of cloud native computing and help mostly the community, the end user community, understand what are the different systems that make up this solution, right? as we kind of talked about in the beginning, the orchestration is complicated, the scheduling is complicated, how all these things fit into the existing systems that are in the enterprise today is complicated, right? And so I think our first goal is really just help simplify the sort of the framework and the architecture for what these systems look like, what type of systems fit into these frameworks. We're trying to bring in projects like Kubernetes and Docker and etcd into the foundation, so that there's sort of a common set of services and APIs and capabilities that you can consume that are known as sort of the cloud native set of services and capabilities, right? And so I think we're still early days in defining exactly what we're going to accomplish, but I think the goal is as I described, is very clear for everyone.
Sure. So
we definitely are not going to get into prescriptions around orchestration and how many clusters and how many connections and which ports and all that kind of fun stuff. But we're not going to get into any implementation specifics, but I think you'll see some reference architectures and some reference, sort of actual user driven best practices, not just a vendor trying to push their best practice, but actually, tested and proven out in user community best practices.
And it all speaks to this need for more advanced thinking about distributed systems, doesn't it? Because if distributed systems do actually have a value for customers, it's going to be in a number of respects, but it's going to be in many respects. For instance, how you can scale up, how you can scale down, how you can find the best, really almost like the best pricing for for your workloads, even based on a spot kind of a basis and such. So you can run your business efficiently, but also developing applications that are differentiated.
Yeah, I think that's right. I think the the differentiation piece is where I think you'll see a lot of enhancements, like we kind of talked about earlier, around some of the prioritization of workloads and the application policy intent stuff, right? I think that's where you're going to see innovation over the next few months and maybe year and a half. It's going to be in sort of the orchestration and the advancements that we can make in that area.
What are some of the advances that you think orchestration platforms need right now?
I think I'll talk kind of at a higher level, and let Ben talk a lot more about some other things that he's been working on as well. But the main areas that I kind of look at with orchestration have to do with how easy is it to just sort of know what's happening at every step of the process. And so by definition, if you're orchestrating a set of services, you need to kind of understand which different pieces are being spun up, and if they are successful at spinning that up, right? And so if you kick off a job, you need to get some type of response back that job has been accepted, that it's been completed, and that it's into the next step. And then you get notification from the next step of the process that it's in this process now, right? And so I think the sort of what I call kind of housekeeping is needed still around that area. And then when you're doing that, I think you can start looking at ways to prioritize and optimize those processes. So I think that's the first set of innovations you see. And I think the second set that we kind of talked about earlier is the application intent, right? So we're going to kind of have some analytical analysis done of this data as you're processing services, as you're processing data. We're going to make real-time decisions based on the business requirements and the business intent needed to really meet the SLAs that they want for those applications to meet. The way that factors into workload scheduling and prioritization, I think, will be a really interesting area over the next 6 months to watch. I don't know, Ben, you want to add anything on pipelining and some of the other interesting things we've been working on?
Yeah, I don't know that there's sort of much beyond what we've talked about earlier, right? I think to be, as you said, like the ability to manage these systems in a very automated fashion, and be able to actually engage not just microservices architectures, but also, legacy applications or legacy solutions, is something that brings a lot of value to customers, right? Because, even though there's like the cloud native is what we believe is the next generation, or is the new stack, you obviously can't abandon your existing solutions and applications and immediately build new value into entirely new systems. So these things have to coexist, and we have to figure out ways to make sure that works well together.
Yeah, I think what's kind of interesting, Alex, in this space is we kind of talked a little bit about user space earlier, right? And I think when you look at being able to sort of have the security baked in to the orchestration layer, so that and are able to sort of validate that you're orchestrating these services and that they're secure destinations that you're orchestrating them to. Whether you call that kind of security of things or container native security, I'm not sure what the right word is for it, but I think that's an area that is really interesting, kind of ties into what Ben was saying a lot, I think, in terms of how do you sort of make these real-time networking decisions that, when it comes to performance and availability, are critical to the business. And today they don't really have a home in this ecosystem. And I think that's where there's going to be a lot of changes in that space, I would say, very quickly as well. The other piece there, Alex, is that Ben kind of mentioned the legacy, and it's something that we kind of touched on in the past, right? That I think is interesting, that when you think about orchestration, right, there's been orchestration systems for a long time, right? Orchestration is not new to the enterprise, but those orchestration systems are mostly focused around kind of business process and operational support systems, right? And kind of early days of the runbook and automating runbook automation, right? And so it's a different kind of orchestration that we're talking about now, but to Ben's point, there are lots of scripts and orchestration tools in use today, and they're not going to just go away tomorrow, right? Most of the business is still running on these tools. And so I think there's something that we've thought a lot about at Cisco, but don't have a strong solution for, an answer for yet, is how do we kind of connect the legacy, or what I would call the state of the orchestration in the enterprise today, to this new set of container orchestration in a way that doesn't force you to rewrite your application or to lift and shift your application, but lets you basically run in a traditional and microservices architecture simultaneously, and then add to that the ability to deploy across multiple clouds and manage your application as a single application instance, even though it might be spread across multiple clouds. I think that sort of wraps up where I think I see this heading very quickly, and something that I know we're very interested in and very, very quickly trying to deliver innovation around inside Cisco.
That circles back to what you're saying about the need to think clearly about application architectures.
Right, exactly. And how do you define your application? How do you compose that or decompose, I should say, right? How do you decompose your application architecture, and which pieces can you move into a more cloud native model versus which pieces, traditionally databases are difficult to do that with, right? Data has a lot of gravity to it, as we all know. So, how do you sort of start with your data where it's at, but over time you can start decoupling that data dependency and making that data dependency more of a service need, and you can start moving the compute closer to the data as well, right, in the meantime. And so I think there's a lot of interesting areas and a lot of research that's happening in that whole data area that's going to be interesting.
Well, good. We're coming, I think, toward the end of this conversation today. We've come along to this point now, and we're starting to see some use cases, right, emerge. But it takes time to understand what the real core use cases are and what the outliers are, because then you can really start to define you can really start to define things a lot better. where are we? I mean, are we starting to see a volume of use cases? We're starting to see what are the core use cases and what are not?
Yeah, I think, Ben, I'll let Ben talk a little bit more about this, but as he kind of mentioned earlier in our conversation, he's talking about kind of the CI/CD type of aspects of what we're seeing is sort of really interesting today. And that's where we're actually seeing a lot of customer interest is around sort of the CI/CD use cases. And I'd say primarily around being able to deploy in sort of two different sort of domains, kind of your internal base and also external, take advantage of external clouds, whether it's for like data sovereignty use cases or for just, the data sits somewhere else, or the customers are out in some other location, or it's just cheaper to spin it up externally than to try to add resources internally, right? That's definitely the top use case that we're seeing. And then kind of the next one that's very close to that, I believe, is sort of the ability to release new applications that we know that the enterprise knows are going to require very quick iterations and changes. And so something that they understand is going to be not a long-standing application that's going to be there for a long time, but it's going to be an application that is going to have lots of constant customer interaction and need constant changes and feedback to it. It makes it very easy decision for them to put that into a cloud native architecture right off the bat. So I'll let Ben add to that.
Yeah, actually, I think you really touched on that last one, on one of the ones that I think is really important too, and I think is becoming, there's been so much talk from the Googles or Netflixes about the value of sort of A/B testing and the blue-green deployments and things like that, right? And being able to like very quickly sort of understand your users' workflows in your applications and adjust the application for better efficiencies, right? Based off that, and I think it is something that we've known there's a lot of value to. We've had like usability surveys and all these things, these like, sort of traditional tools, but there's nothing that I think is more effective than getting the feedback based off observation of your users, right? And I think, that is very tightly coupled ultimately with your software delivery pipeline or so forth, like having the ability to sort of manage these discrete deployments or instances of a microservice and be able to identify and collect data from one. And again, it's that data analysis that is really the business value there, right? So being able to deploy the application is useful, but being able to then collect that data and have that data access and that data analysis be able to quickly feed back into your development team to provide some work items for the next iterations and so forth is highly, highly valuable and can shorten development cycles, I think, greatly.
But I was hoping you could also maybe spend a few seconds talking about the kind of the ability to quickly upgrade or to kind of do rolling upgrades in some of the customer use cases we've been working on.
Yeah, and I think, again, so in so much of my mind, these all sort of fall directly out of having a really well-defined CI/CD pipeline. But yes, like the continuous upgrades, the system resiliency. I think when you look at we've been working pretty closely with some service provider use cases, or some service providers around some of their use cases, and they obviously have huge amounts of data that they're processing and dealing with, and and interface directly with consumers, right? And nobody is louder than a consumer when there's a problem. And so they want to be able to be very reactive and quick, but at the same time not have any downtime when they're actually delivering these system updates and sort of recovering the system. So again, if you have that sort of SDLC pipeline, the software delivery pipeline that lets you, very quickly validate new software, by making changes, get it integrated, get the testing done, and then roll it out in a way that provides the least amount of service interruption. And really, ideally, if you're writing the end user application, you can make it basically appear as though there was no service interruption. I think that's the ideal that everybody is going for.
And so we're not saying that we are there today, Alex, but we feel like this sort of an architecture is going to finally deliver what we've all been looking for forever, which is 100% user experience uptime, right? So
right.
Never going down, or at least never having an outage that is visible to any user. I think we see this being the closest set of technologies that can get us there, because it truly keeps the application and the user experience separate from what's happening underneath the covers.
Yeah, and again, not to minimize, there's plenty to do in software architectures to enable that, to really understand that. And I think that's one area that we've also been working on too, is how can we help develop that knowledge and train people to start building and architecting their software in this way and adopting these policies. And obviously we're not alone in this, right? There's Agile is the word of the day for, I think, any software development, which is excellent and is a great starting point, but there's still more to be done to make sure that everybody is successful here.
Well, this has been a really great conversation, guys. Thank you very much for taking the time to talk. I think we could, we have a lot to talk about this year as we go forward. It's given me a lot of things to follow up on. So thank you very much for your own time, Ken and Ben. Thanks for your time, and we'll be in touch, I'm sure, in very short order.
Yeah, thanks, Alex. As always, it's great to be able to catch up with you in the new stack.
Yeah, it's been a pleasure. Thank you very much, Alex.